Okay, so we are talking about accuracy and precision today. Percent error also, but scientific notation we'll probably do on a different video. This will be just accuracy and precision for this particular time. We'll do accuracy and precision next time. Or no, scientific notation next time. So when we think about accuracy and precision, mainly accuracy, you think about aim. So in a sport that you aim is like darts or archery or something along those lines. Either way, you need a bullseye, so a target to aim at. So when we think about accuracy, aim, you want your aim to be perfect. So we aim at the center. So accurate is accuracy towards the center. Now accuracy can be repeated. So if I repeatedly hit my target, I am getting something that's called precision. So consistency, precision and consistency belong together. So precision is how consistent are you over time. Now I could be, in science, we want to be both. We want to be both consistent and precise. We want that precision to continue throughout our tests to make sure that this testable project or this testable substance is the same over and over and over again. Now, it is possible to have precision without accuracy, because for instance, if I'm aiming at my target and I see that I keep on hitting far off to the right and up, I am precise with what I'm doing. So maybe if it's like a gun or an arrow or a bow, there's something wrong with my sights. If I keep on hitting the same spot over and over and over again, this can give me a answer to my question as well. So precision is what we look for most often, but we really want accuracy too to make sure our things are right. So with that being said, the following measurements with this video example were made to determine the density of a material whose value was, according to the Handbook of Chemistry and Physics, 1.24 grams per milliliter. Now in our trials, we were able to get 1.20 grams per milliliter and 1.22 grams per milliliter twice. So you could say, well, yes, I was actually very precise with this. Precise with my measurements. And if I want to say that my accuracy was within 2/100ths, then yes, I am accurate as well. Now, if I wanted to get it within a 100th of what I'm looking at, then I'm not accurate. But in this case, I'm getting pretty close. I'm getting to where I want it to be. If I were to do density, I'm going to see that around the same amount. Now, if we have a measurement was taken 3 times, we want to get to 68.1 milliliters. So circle which measurements were accurate, precise, or both, neither, that type of thing. So with this, we have 78.1 milliliters in our first trial. Second one, part 1, is 43.9, and then 2. We're not accurate. None of those are 68.1 or even close, and which means we can't be both. And we're definitely not precise because you have a 2 and a 78 on there, so that is definitely neither. It's not in a good spot. Now, if we do a 68.1, 68.2, 68.0, we are very close. We are exactly on one of ours, and we're almost exactly on the other 2. So we are very accurate, and we are very precise, which means that we're both in this case. So if we have both, we want to make sure that we write both. But now, in this particular trial, something must be off of whatever we're measuring or whatever we're using to measure, because we have 98.0, 98.2, 97.9. We're very close on it, so we are precise on all of those, but we are not accurate, so it can't be both, because we're still 30 away from what we want. Now, on our part D, we have a 72, a 60.3, and a 68.1. So in this case, we are not precise, so it can't be precise at all. So it can't be both. But there is one that is accurate because it's perfect, spot on. And then we have 2 that are neither, so not accurate. So it's possible to be accurate with one, but not accurate in total for your thing. Maybe you fix something which you finally do it at the end. All right? You do not have to do the honors section, so don't worry about that. Now, the second part of this deals with our percent error. So when we think about percent error, look at our goal is to be around 1 to 2% off. If I were doing an experiment, I would want to be within 2% to say that I was correct. If I'm any more than that, then I'm probably need to start something again. So just being 5% off, it's close in the reality of things, but that's still not close enough for me to get the correct answer. So if I look at the first one where it says Joshua used a thermometer, finds the boiling point of ethyl alcohol is 75 degrees Celsius. He looks at the reference book and he finds that the actual boiling point is 80 degrees Celsius. So if we look at our formula, we have your answer, which is Joshua's answer in this case, and we have the accepted value, which according to the book, reference book, is 80. So we take this and we take the absolute value of it. All right. So that means that 75 minus 8 is negative 5, but the absolute value is 5 degrees Celsius. And we'll take that and divide it from our 80 degrees Celsius. These two cancel out. That gives us whatever this answer is times 100 to give us our percentage. So in this case it is 0.062 or 0.063. So if we get this, we get 6.3%. So in this case, we are not in that 2, even 3% range. So I would try again. Not close enough. So we would need to try again because that 6% isn't good enough. Now, Ariel weighed an object on her balance and recorded a mass of 24.3 grams. Her teacher told her that there was obviously something wrong with her balance because it was giving her a reading in which it was too high. It was actually too low. The teacher showed the recorded mass was actually 32.1 grams. So in this case, our gathered value is 24.3 grams, and our known value is 32.1 grams. So we're going to subtract those, get 7.8 grams. We'll divide that by our known, which is 32.1 grams. Grams cancel out because they are on the opposite sides of the division. And that gives us a 0.243 times 100, which is 24.3%. If you ever think about percent, the percent symbol is actually just 100, written in a fun way. So in this case, we would be way off. Try new scale. That would be our inference from that. All right, so what you need to do, go ahead and do numbers 1, 2, and 3. If you feel like you need more information, please do the honors section, which is 4 and 5. But if you don't, just go ahead and do the extended thinking, which is both the bullseyes and coming up with your own real life accuracy and precision. So you need accuracy, precision, and both. Cannot use the bullseye. All right. If you have any questions, please email me. That is today's assignment. Thanks for listening, and that's it. Have a nice day.